All right, number 67 is a substitution problem. You let u be 1 plus 2x, 2 sine of x, which makes the derivative 2 cos of x dx, which produces this 1/2 out in front, because it'd be 1/2 du equals cos x dx. So you have 1/2 du over u, which du over u is the same thing as u to the negative 1, and that produces natural log. That's the only time that you cannot use the power rule, when it's to the u to the negative 1 or x to the negative 1, whatever. So it's natural log 1/2 natural log of 1 plus 2 sine of x. Now be very careful on these kind of problems, because if that 1 plus 2 sine of x, if it's in parentheses raised to some power other than 1, or under a radical sign, any kind of radical, which also is a fractional exponent, anything like that, you would use the power rule. Sometimes students get that confused. When they see something on the bottom as their u, they want to automatically call it ln of x. But that's only when the denominator is u to the first power, like it is right here, right there, u to the first. If that ends up being raised, if that u, which that's still the same u, but if that u is raised to any other exponent, and you can see examples of that in my notes on the natural log section of integration. Yeah, so just be careful with that. I don't think that would have been a problem for this particular choice of answers, because they all say ln, and then there's just kind of a dummy answer there for C. But that's good to know for moving on to Cal 2, or just in case the problem was different, in a test. Number 68, you have to use division because the fraction's improper. The definition of improper technically is that the power is on top is greater than or equal to the power on bottom. So if that had been 10x squared on the bottom, we still would have divided. Okay, so I come over here and divide 20x squared plus 28x, 10x minus 1. So basically 10x goes into 20x squared 2x times. So I take 2x times 10x, which is 20x squared, 2x minus 1, which is negative 2x. Always remember when you're doing division this way, kind of going back to elementary school or whenever you did it by hand, that's subtraction. So it's 28x minus a minus 2x. So that'd be real tempting to think that was 26x right there, but I know it's 30 because it's 28 minus a minus 2. So then you go, okay, 10x, and then we have 30x left. So whenever those powers are the same, that means you're about to do your last division step. So 10x goes into 30x plus 3 times. So you take 3 times 10x, which is 30x, 3 times negative 1, which is negative 3. So once again, that subtraction, now I didn't show it there, but technically there's a 0. I know it would look real tempting just to bring the negative 3 down. That's not right. Really, it's 0 minus a minus 3. So that makes it plus 3. So we have 3 right here. So you have a quotient of 2x plus 3, and then the remainder will be 3 divided by that divisor, I believe it's called, 10x minus 1. So it's 2x plus 3. So that fraction now is equivalent to 2x plus 3 plus 3 divided by 10x minus 1, which we can integrate pretty easily. First two terms especially. Antiderivative of 2x would be x squared. Antiderivative of 3 would be 3x. And here I can let u be 10x minus 1. So du is 10x, so therefore I'd have a 1/10 out there. So if I pull the 3 out and then pull out the 1 over 10, that would give me 3 over 10. And I have du over u. So that gives me natural log of u. So it'd be x squared plus 3x plus 3/10 natural log of 10x minus 1 plus c. So there it is, answer C. Now here's the classic derivative of the inverse problem. So let's see what we have here. Now notice that the intervals between -1 and 1, because actually there's another value, 2, that would satisfy the equation we have to solve here. A lot of people have trouble with this, but really it's not that difficult. I don't have the formula here, but you would have it, on your test. It's basically the inverse derivative of your value A is 1 over f prime the value B, and the value B is where f of B equals A. In other words, so if you take your original function, substitute B in here, you don't have to do B, but it kind of matches the definition. Set that equal to f of B, let's see, so set that equal to 5, which is the A right here. So you move it over 5. These problems are always designed, on my test, whether it's a regular exam, third exam, or the final, to where these work out to be nice, clean, whole numbers. They're not going to be something where you'd have to graph it in a calculator and look at the intercept and get some weird decimal value. You can pretty much get it by trial and error. When you move the 5 over here, b cubed minus 4b, you'll get b equals 0. But actually, like I said, two other values work here. I believe -2 and +2 would give you 0. If you factor out a b, you'd have b squared minus 4 here. So that would give you two other values. But anyway, if that's therefore that's why this is between -1 and 1, because we're only looking for the 1. It's the 0 here. So we had to restrict it. Now, so if the b is 0, that means the derivative of the inverse at 5 would equal 1 over the derivative of the original function at 0. So the derivative of the original function is 3x squared minus 4. So if you put 0 in there, that would give you -4. So the derivative would be 1 over f prime of 0. So it would be 1 over -4. So therefore, it's -1 over 4. So it's answer C. Now we have the derivative of e raised to the 7 minus 9x. Sometimes the font on this program is harder to tell. It should be easier on the exams to tell. But you can kind of see, if you look carefully there, you could even use a piece of paper or something, but all of that's raised 7 minus 9x. So it's e raised to all that, 7 minus 9x. So basically the derivative of e to the u is e to the u du. So it's e to the 7 minus 9x times the derivative of 7 minus 9x. So that would be -9. So the final answer then would be -9 e to the 7 minus 9x. All right, number 71. G of x equals e to the 3x cosine of 2x. Got a little product rule going here. That's just the order I choose to do the product rule. Keep in mind the answer choices could be in the other order, but that would not be too difficult to rearrange that. So if I go this order, and f prime, the derivative of e to the 3x, remember you'd have to take the derivative of the exponent 3x, which is 3. So that's what makes that 3e to the 3x, because the derivative of e to the u is e to the u du. So it's 3e to the 3x times cos of 2x plus the f, which is e to the 3x, times the derivative of cos of 2x. So we have to remember two things here. The derivative of cosine is negative sine, but the chain rule says we have to take the derivative of that 2x. Very easy for students to forget. Sometimes in class I'll just ask, what's the derivative of cosine of 2x? And somebody will go, negative sine of 2x, which is close, but it's not right without the 2. Chain rule, got to take the derivative of that 2x. So it's -2 sine 2x, so I put the -2 in front, makes that negative, and then it perfectly, so here's the answer in pink, and that perfectly matches answer choice B. So be very cognizant of the chain rule. 72. If you let u equal the exponent, negative x to the 7th, that's going to work out perfectly because the derivative will then give you negative 7x to the 6 dx, and that's going to give you that x to the 6 in front. Now you divide both sides by negative 1 over 7, so that gives you the negative 1 over 7 out here. And then you have negative 1 over 7, and then basically e to the u du. That might be about the easiest integral you can have once in that form, because you don't have to do plus 1 or anything like that. The antiderivative of e to the u du is just e to the u. So it would be negative 1/7 e to the u. So then it would be negative 1/7 e to the negative x to the 7th plus c. So that was a real straightforward integration for e. Now, most of the time you are looking for the exponent to be the u whenever you integrate e, but there are some exceptions to that, and this is one of them. Because in this case, it would make no sense for 2 theta to be the u here. You have to let u be the entire denominator, 1 plus e to the 2 theta. Now, you might think, what about just e to the 2 theta? But the rule of thumb is if you can include more terms, like the constant, you want to include it. That's the right way to do it. Because the 1, doesn't affect the derivative, and actually you have to do it. There's no choice. You have to include the 1 plus in there. So that derivative, chain rule, e to the 2 theta would be 2 e to the 2 theta d theta. Chain rule here, so that makes that a 1/2. So it puts a 1/2 out in front. So we have basically e to the 2 theta. That's d theta is 1/2 du on top, and the 1/2 comes out. U on bottom, so we have du over u, and that's just natural log of u. So you end up with 1/2 natural log of u, and which will then be 1/2 natural log of 1 plus e to the 2 theta plus c, which matches answer A perfectly. Number 74, now we go back to letting u be the exponent here. So the exponent would be, as you see, I wrote that. I think it makes it a little easier for this kind of problem if you do what I did here. If you rewrite e to the 1 over x, make that x to the negative 1, and bring that x squared up, not the 4, just the x squared, and make that x to the negative 2, and then that 4 stays on bottom and comes out and it just remains 1/4. So leave the 1/4 out there now. Now everything's in more of a linear looking kind of fashion, no fraction of variables, fractions. So you look at this, because it might look kind of weird at first, but then if you kind of go, oh, okay, if I let u be x to the negative 1, oh, okay, now I see. I take the derivative of that, and that gets me the x to the negative 2. Because it might have been hard to visually see what was going to happen with that problem, and I do one like this in my notes. Same thing with radicals. You see a radical like this, you might see that on the test, where it's like a root and a root, and you're going, how's that going to work? Well, if you rewrite it like this with fractional exponents, you'll see that letting the u be the exponent here, and then the derivative will give you the other exponent. So now it fits perfectly, except for the negative would come out here. You have x to the negative 2 dx, pull the negative out. So it's negative 1/4 e to the u du. So it's negative 1/4 e to the, which of course u is x to the negative 1, which, I would have considered perfectly fine on a handwritten test or something. But just to make it match that answer, I rewrote the x to the negative 1 as 1 over x to make it match answer D. So it's negative 1/4 e to the 1 over x plus c, which is the same thing as just putting the 4 on the bottom. So D is definitely the correct answer for that one. All right, so here's the formula you'd be given for the derivative. We've seen natural log, but then there's the formula for the log of any base, which this formula actually works for natural log too, if you think about it, because natural log is log base e. So if you put e in here, ln of e is just 1, so you end up with 1 over u du dx. So basically it's du dx over u. So really this formula incorporates all log derivatives, including natural log. So you just follow this formula. It's not too difficult. So you take the derivative of what's on the inside here over what's on the inside with an ln of 7 on bottom. So the derivative of the inside here would be 2x minus 6 over the x squared minus 6x minus 2 times natural log of 7, and it fits answer D beautifully. So that's correct. Now here's another one of those that is raised to an exponent. It's hard to tell from the font. Like we did one like that with the E earlier, but that is all one big exponent. If you look at it real carefully, you can see it's elevated above the 8. So here's the formula for that, which just also works for e to the u. Once again, because if you let e be there, ln of e is 1, you would just have e to the u du, e to the u du dx. So that formula works for all numerical bases. And so we follow this formula. So the u is 4x squared plus 9x. So it's a to the u. So that original derivative is part of the answer for sure. 8 to the 4x squared plus 9x. So that pretty much eliminates answer B automatically. ln of whatever your base is. So it's ln of 8 goes there. And then the last part will be the derivative of that exponent. So the derivative of 4x squared plus 9x would be 8x plus 9. Now there's the answer. So it has 3 components. Now, of course, the answer choice may not have the components in the same order that I just did it. And in this case, it does not. But that is not too mathematically difficult to look at what you have here in pink and match it up to answer D. It's just the 8x squared, the 8x plus 9 was just moved to the front. So that's no trouble. But it's those 3 components, regardless of what order they list them in the answer. And number 77 is a logarithmic differentiation. That's the only way that you can take a derivative when you have a variable in your base and a variable in your exponent. There's no preset rule. You have to follow this process. And, often the answers can kind of look ugly, but you're not trying to simplify or anything, so it's not that bad. So what you do is we have to get that exponent x to come down. So you take ln of both sides, which I did right here, and that allows this x to hop in front, right there. So it's x ln of cos x. Now we have to do a product rule here. Now the derivative of the left side would always be basically the chain rule. In a sense, the derivative of ln of x is 1 over x, but we're assuming, that y is, which it is, a function of x. So it's kind of like, how the derivative of ln of u is u prime over u. Same principle here. The derivative of ln of y would be y prime over y. You could also think of it sort of like implicit differentiation also. But once you know that, it's the same thing every time, y prime over y. But now we have to do a product rule on the right side. So I'll use this version of the product rule, and I can rearrange my terms if I have to. So the derivative f prime, the derivative of x would just be 1 times your g, which is ln of cos of x, plus your f, which is x, times the derivative of ln of cos of x, which the derivative of ln of u is u prime over u. So it's the derivative of cos x over cos x. So it's negative sine x over cos x. So that turns the middle sign, this negative, now makes that negative. And then sine divided by cosine becomes tangent. So you have, so what I did here is brought the y up to the other side. And so it's going to be y times ln of cos of x minus x times tan of x. Well, we know what y is. Y is the original function, cos of x to the x. So you just replace y with cos of x to the x. So your original function would always be part of the answer. So that kind of rules out answers A and C. They don't make any sense, but you see that B and D both have that cos of x to the x in there. So they have a chance of being right. But only answer B is right because of what's the ln of cos of x minus x tan of x. And then with the cos of x raised to the x in front. And that is the last problem.